Hi everyone, welcome back again to my channel. This is part 3 of the DIY A320 Neo Home Cockpit video. In this part 3, we're gonna talk about the build process of the overhead panels, which is I think I tackle this one first, as mentioned, because of the Corey switch. Okay, as you can see, the panels, the A320 cockpit basically are filled with a lot of Corey switch, right? So without that switch, I think it's not going to be A320 cockpit. Okay, so before we go ahead, I have a bit of like a list of website that I'm using also in the initial part of the build to do a reference, to find a reference. Though I mentioned also I bought a A320 cockpit poster. I'll show you later on in the Coreldraw, and also A320 cockpit 3D models for the blenders. So I bought that in the website, and I bought several 3D models like the tiller and other, which I cannot share because that's copyrighted. Of course, you have to pay for it, but you can find in the website. But this one is the initial website that I'm using for a reference, the measurement of the A320. I forgot to list it. I will put down in the description below on the list so you can take a look. Okay. Going back into overhead panels. So this is the hot topic, which is the Corey switch. Corey switch is a switch where it's a brand actually. It's a company who's created this kind of switch where the switch is momentary push or latch push on off button, but it has a light in it. Okay, so it can be light up like this, like mostly two halves, above or below, or only one lighted. Uh, this is very famous, as you can see here in the overhead of the A320. There's a lot of Corey switch being used. Either the push, this at least 110 that I count, Corey type switch or display. Overall, the cockpit, like in the overhead, especially a lot of them, like almost 70 of them, and then the other panels that's used a lot of course, which also is the MIP or the main instrument panel in front of us, like the where the ND ECAM display are there, like for the gear, for the auto brake, that's Corey switch, and also several small numbers of Corey switch or display in the pedestal for the fire display, and also for the door, for example, and other things. So yeah, but mainly in the overhead especially, and then also in the main instrument panel, and then some small number in the pedestal. There's a 67 at least Corey switch with the latch type. So latch mean you push and it's locked into on, or if you push again, it's going into off position and stay there. There's 32 Corey switch at least in momentary type, meaning that if you push, it will spring back into the initial positions. So yeah, so it's kind of like for external power, it's going to be used momentary, but for fuel pump or a master APU switch, for example, that is a latch type, for example. So I have a list of it. I'll show you. Hold on. This is the list. You can I've created a Excel sheet where you can find out all the button, the switches. Actually, this is supposed to be, yeah, this one is for the overhead panel. So I'm going to share to you, this one is the IO list for the overhead panels only, not in the MIP and other panels. I list down type of switch. Here TG mean toggle or latch type of Corey switch, where empty is momentary type of Corey switch. The two position switch is mostly the toggle, like a lever, right, type. So for landing gear, these three positions, I list down this one because each of them require a pin, right, or the IO. So yeah, so basically this is just a list down of the. So if you see here, there is input output. So input is the switch itself, on off, momentary or latch, but the upper and lower is the display or the LED light in the switch. So this one has the fault orange color above and on blue lower. So how do I map this one? I try myself on and off using the simulation itself or inside MS FS2020 and try to play around with it inside and then take notes. So it's take a lot of effort. So yeah, so but it should be good if you start the build of the overhead. At least you don't have to find out, is it latch or is it momentary, what color in the upper position of the LED and what color in the lower position. So hopefully this is already accurate. If not, then you let me know also. Okay, so that's one is one input and two output here. Okay, here if it's this one is meaning that it only have one output, which is the lower part here, but the upper part is not required. But here too, meaning that two output required to drive the LED. Okay, this one is the list. So I'm connecting it to the CPU or into a shift registers. I mentioned don't worry about this, it's my own design, but you probably have a different kind of arrangement. Okay, so this one is at least 11 panels in the overhead, meaning that the first one I put it is the anti-ice and lights, the bottom center, and then the flight control emergency oxygen, that's the left part of the bottom part, and then air conditioning is the above the P1 or the light and anti-ice panel. This is mostly air conditioner, and then electrical above it again, hydraulic fuel above again, and the top one is actually the fire extinguishing or the fire extinguisher panel, and then the flight control left is the above the P2, and then ADIRS the top left, and car van, actually this one is on the left or right. Right, yeah, this is the right, bottom right, this is above that one, and then PA video is the top left panel. Okay, so this one you can use later on. I'm going to post it in my Google Drive. So going back, okay, so the once you know the panels and then the number of core switch, this is a lot. So I need to, as I mentioned, I need to fix this one. I have to be able to produce this one first before I go even build the whole cockpit, right? So once I'm able to create a reliable core switch, then I proceed with the panel itself. So I've been doing a lot of iterations, sizes, and turned out that I found out the right one is actually the final version of the core switch, while the left one is the first one. There's several you know, kind of experimental board, but the 3D is actually the size is actually almost right. This one is using a square, very thin square aluminum tube, which I have to cut and bend the outer lips, and then create my I've created my own PCB. Actually, I'll show you later in the video in the camera, and then put the LED inside. So I put a kind of reflective tape in the center, so the 3D model is actually printed on white, so it's kind of more reflective, but I add another what do you call it, aluminum tape, then to cover the both sides of the center, because if not the light is actually bleeding to each other, because it's quite translucent. The 3D printing is very thin. It's probably around less than 2 millimeters or 1.5 millimeter or 2 millimeter, I forgot, but actually it's quite thin, so the light from one of another kind of bleed through the center and then light up the other section. So I have to separate this with some kind of reflective tape or aluminum tape. It's also helped to reflect back and then focus the light inside its chamber. The construction actually is this is the case of the LED, and then below that there's a micro switch that I'm using, and the LED pin actually pushed through to the PCB and then soldered there, and kind of like acting as the rail, a guiding rail for this housing to move up and down based on the switch, uh, kind of tips of the switch. So I'll show you later on in the video how it works, but it's connected to the cables for the LED and for the switch. The switch use 2 pins cable, red and black cable, and the LED use 3-pin cable. This is a pre-made cable I bought in China because it's much easier just to use it without trying to solder each cable, because I'm going to do it 100 times at least to do this. So I'm using a jig also to cut this aluminum. I create a jig with 3D printing. I cannot show you later on. I cannot show you today, but it's a jig to cut the length of the aluminum exactly as it is, and using a circular saw, or no, a band saw to cut the aluminum tube exactly the length that I want, and then cut the pin to bend toward the PCB. I'll show you in the video right now. Let me see. Okay, so this is the constructions. Basically, initially it's like there's a case. This one is not painted in aluminum color, but you can see it's very smooth. Why I'm prefer to use aluminum and the 3D printing material inside. So if you use 3D printing in both sides, and I'm using FDM materials, not the resin, because resin is a bit brittle and kind of like not durable, but I'm using this, if not mistaken, a PETG material, so it's quite durable, white PETG color FDM or filament. It's quite durable, but if you use the inner casing for the LED 3D printed, and the outer casing also 3D printed, you can do that, no problem. But by design you can do that, but when you put together, they will have a bit of friction, okay, from each other, because you have to layer vertically like this. Yeah, well, you can do it actually in the opposing directions to prevent some binding of the plastic, both plastic wall and the inner side. So I prefer to use the aluminum because it's just to ensure the smooth lining inside this. I spray some silicone lubricant, and it's really reliable. Okay, so this is the initial build. I'm using the perforated PCB and some just some kind of resistor. But this one is actually the PCB that the second PCB that I created, a single side PCB. Not very good. Sometimes it's just loose in terms of the copper. So this is the lower grade PCB, but you can see there's a resistor already built in, and the construction of the 3D printed inner casing will be butt into this tips of this. So you can see it's like this. This is a latch version, so it's on and off, so it's lock and off. So this is the latch version. So this is the second version of the build. The final version PCB is like something. By the way, I don't have the blank one. Oh, sorry, wait. Oh yeah, this one is the second one, the third one. So this is the more successful version. So it's much more durable, dual layer. So just to ensure this, the line is the PCB copper is good, and the cable actually in the bottom part, not in the side. So basically like this. This one is, I've already dismantled the LED. I cut LED because it's broken, but I run it all. I'm using all the PCB until the last one. So unfortunately I cannot show you the working one. I already installed everything in the cockpit, so I don't have any spare left actually, but it will be like this. So the cable initially going up like this in the side of the casing, so it's very difficult to what do you call it, to install, especially when you are installing it to the to the panels. And also the third version do not have any resistor anymore. Initially the resistor is put here in the PCB, but in the third version the resistor is moved into the driver, not here but into the LED driver board outside this PCB. So the PCB is very simple, just the switch and LED. So this one is going to go like this. The switch will be inside. For example, this one is like this. Pretend the switch is broken, so it's missing the head, but then it will be put like this, and it will be there's a tab here that I cut with the saw to create a small tab here, both sides, and this will push into the hole of the PCB, something like this, and you can bend the lid, so the aluminum will stay like this, but the inner side will be on and off. It's broken. Unfortunately, it's broken one. So it's like this. Yeah. So it's this one is a bit tight, but I think it's not the right size. But it should be very smooth, like this one. Although this one is the first size, also the size of the aluminum is a bit different. This one is, I was taken, is almost 2 centimeters, so 20 millimeters times 20 millimeters, the size of this switch. And I kind of bend a bit the lip in the topmost. This is to stay within the panels, so it won't so it will stay there. So for example, I'll show you the panels. This is the panel, for example. This is the panel, and it will sit into the third layer, the 3 millimeters, something like this. So it won't show up. I'm painting this all black, so it will not kind of visible. The silver color is not visible, so it will stay like this in the third acrylics, and the 3 millimeter third layer acrylic, and will stay like this, and the switch will be here. Okay, something like this. Okay, so this is the final construction, and it's working very well. Yeah, so many iterations in coming up with this Corey switch. This is the one that I like, the last one. And which one? Oh, sorry, the broken one. Yeah, so unfortunately the switch has been broken, pulled out and broken, but this one, the PCB is good. This one I created a lot of this aluminum, almost 120 something. I forgot where I put it. I painted black and then put the silicone lubricant here, and yeah, and this also been kind of smoothened a bit on the side, and you put a reflective tape inside, and there's a hole inside the 3D printing, so that is where the LED like this, so LED sits in over there, and yeah, it's going to be light up. So this one is the fixed version, meaning that this is for the display only, so there's no switch. This one is for display, a single display lower half, for example. So that's example of the display. So it's fixed, so it's glued into the PCB, so you just connect the cable to light up the LED. So this one is the example of the LED inside. Took different color, usually orange and blue, or orange and white, and yeah, so it's working very well. And it's not easily pop off, because I designed the hole here very tightly fit into the tip of the switch, so it's kind of like stay there. Even if you need to, you can glue a bit on the power glue, but you will be having difficulty in replacing it if it's broken. But yeah, it's quite durable. Yeah, the switch is a micro switch, a 6-pin micro switch. This is a latch type, meaning it will stay on one position, and one of the two positions. And this one is the momentary switch, so it's kind of spring back into initial position. So that is the Corey switch. I also create kind of this is just using a experimental board. This one is actually connecting to the switch itself, like just connect here. You can test the lights inside it using this powered through 5 volts. Um, then you can press here to light up the LED inside each of the chamber. You can test it, and if you press the on off button here, this LED will light up also. So it is actually a tester board. You have to have this one because from 100 Cori switch, you're gonna find one of them failed or wrong. You kind of soldered the LED backward or broken switch or whatever it is. So this is a quality control, a simple one that I created to test all the Cori switch that I made. So very important for the, even because this is DIY, only one cockpit, but because you create 100 of Cori switch, you require a quality control somehow, because you don't want to find out that once you install it in the panel, it doesn't work. So you have to open up again, unglue, or using hot glue to attach this into the panel so it's stick and do not slide or slide out or kind of fall. You have to unglue again, you have to fix again. It's a painful process, I guess. So that is the main Cori switch problem you have to handle, and I'll give all the design later on in the Google Drive, so you can also tweak or whatever. So after that, actually, sorry, you see the, if you see here, hold on, yeah. So let me show the camera again. So I forgot to tell you that to cover these two LED chamber, I mentioned also putting a reflective tape in the middle to just ensure that the LED is not bleed into another chamber, the next chamber. And also I create this cover using acrylic, 2mm acrylic thickness. This one is actually not an opaque white, so it's a bit of white, translucent white. Either way is okay. I create a lot of them. I create a set of it just in case, because some are usually, so yeah, so they have a different so I put there a Coreldraw design for this, so you can just cut through the acrylic and paint it black and then engrave it. So basically you put this cover on top of this LED, but also because if you put like this, the marking is quite visible, right? While actually in the cockpit, it's actually dark. If it's not light up, you cannot see this white marking. So what I did, actually, I put a what do you call it? A film, a darkened film for the glass, for a car automotive film, to darken your windows. So I put that film on top of this. It's quite okay, although sometimes it's kind of peel off a bit in the edge, but yeah, you can make it, you can glue it perfectly or whatever, but you have to clean it up first with alcohol just to ensure there's no oil, and then you attach that film, darken, I think around 25%, or yeah, 25% darkening effect. It's already enough, or even 40% if you want to, but the darker it is, the light is become a bit dim. I think 20% should be okay to darken this cover. Okay, so if it's covered, you will look into a dark switch when it's not light up, and when it's light up, it will show the color of the LED that you use, usually orange LED. Choose the clear one, or I think the 2.2 volt one, or I forgot, but use the higher ampere current one. Use the higher current rating one, so it's light up brightly rather than the red color or the green color LED that usually not light up very bright. So choose the brightest LED that you can use inside, and it will show quite perfectly okay. Okay, so that's how I cover the Cori switch. So if you see here in the slide, so this is the cover that I already paint with the gloss black. Once you cut through acrylic laser cutting machines, this is I forgot. I think you have to reduce slightly bit because it's a recessed panel into the 3D design, and then you paint it both side, all side actually black to cover all the this one side of the acrylic white, translucent white acrylic, and then after that you have to laser cut, engrave, sorry, laser engrave. So I put back into the its original cutout, and then but then change the mode into engraving the letter or the marking here. So once you cut it, don't pull out this tape. So just let it there, let it sit there, because if not, then you have to realign again, and then put back the painted one in back into the cutout, the hole that is being cut. So once it is all positions, the black facing upside, and then you run again the machine with the engraving letter. So you're gonna have a perfect positioning of the letter without the need to realign the zero position of this laser head. So once you engrave it, you have those cover that I just show you with the very crisp lettering, for the Cori switch cover. So that's how I made my Cori switch, and I think it's beautifully looking in the cockpit right now and working perfectly well. It's well lubricated with the silicone lubricant, and until today I haven't really found any issues with that Cori switch. Okay, so that is the Cori switch. Let's move on to other switch, because once I deal with the Cori switch, I also prep the other switch, because just to ensure that the switch that I'm using is the one that going to be designed into the panels, the holes, the positions, the size. Yeah. The knobs also, just before I move on, the knobs is actually like this. There's a lot of knobs in the overhead. This is just example of some of the knobs. I know the design is not perfectly well. It's just be a bit rounded here, but yeah, I'm quite the difficult also, you have, once you have painted with gray, light gray, and then you have to cover with some masking tape and paint it white, and then you have to mask again to paint the middle with a very thin tape, and then you paint it black. So you have this outside black and inner white. So it's quite cool. And then several others actually is painted silver for the landing gear lights. This one is with the resin 3D printing, so it's much smoother. So this one is for the other lights actually in the lighting panels. Later on you're gonna see it. So that is the other knobs and switch. If you can see here, I painted gray first, and then some of them are painted silver for the tip of the switch. This one is the example that I just show you, the light switch being installed into this 3-position switch. I'm gonna tell you later on how to wire the 3-position switch, because this is on off on, but becoming on on on. So I don't do any modification to inside this switch, but I'm using a NAND logic gate to derive the third position here, the middle position, into on by NAND gate. So NAND gate meaning that if it's off here, it will be on here. Okay, so using NAND logic gate, so you can do triple positions on using that. If it's one on, 1 and 0 here, the center will be 0 definitely, because a NAND logic gate. If it's 0 here and 1 here, it also 0 here. But if it's 0 0, it will be 1 here. So you will be able to do a triple position switch without any modification on the internal of the switch. Initially I do that and it's very unreliable, and sometimes you get it, sometimes you don't get it. So by doing electronically, because you don't need physical contact anyway, you just need the logic to appear in the output of the switch. You just use NAND logic gate. Okay, invert and logic gate. Okay, NAND. So I'll probably talk about that later on, but this is just example of it. By the way, I don't use this switch anymore. I'll show you the switch that I'm using. I'm using this switch actually. Actually, this one, if you can, this is actually a grinded switch. So the initial switch is something like this, but I grind it flat, something like this. So it's actually around 1.5 millimeters thick. So I grind it into a grinding machine, so it becoming a flat switch step like this. Because initially, if you see in the slide just now, it's actually a very short tab, and it's very unreliable. So if you attach that to that kind of switch, it will kind of wobble a bit. But with this long shaft being grinded, and then you put inside this one is the first version. So the latest version have a longer inside shaft or hole, where you can shove in you put this switch into this tab, and it's very strong, and you can glue it up. Sorry, you don't need to glue it up, because it's very strong. Because once you glue it up, you cannot take it out, because it will stuck into the panels. Yeah, so that's how I created. You can create a bit of screw mount, like a tightening screw here if you want to, but this is very brittle. The resin is very brittle, so you have to be careful working with the resin compared to FDM. This is just example of the switch that's been glued for the light switch, I think for the taxi light or something. Yeah, but this one has been glued, just for example. I do use a lot of toggle, but this one is the better version of it. This one is also a better version of the toggle switch. This one is also been grinded for 3 positions dual gang, but usually you can single gang is okay. Single single pole, two pole, 3 pole single gang, and this one is dual. But you don't need this one. If sorry, some of it actually use this one, because if you want to read the position into the FSFS to imitate, then you use the other half to kind of giving you a feedback where the switch position is. But yeah, you don't need that one in my opinion. Okay, so that is the switch for the lighting. Usually the other things that I created in the upper the overhead panels is the cover, right? So some switch or some push button, like let me show you. There are some buttons, okay, that actually, let me show you the switch. This switch actually for certain button that's actually being covered. So this is just a momentary push button, but that switch is being covered in the panels. Now the cover of the panels either actually is like this, like fully covered, fully enclosed, or something like being cage. There's a cage kind of type cover. I'll show you how to make it. This one is being printed. I already gonna give you the, how do you call it, the files. So basically it's you see this is being printed in a 3D print. Okay, later on I'm gonna give you the files, the 3D files, so you can print your own. The cover is painted red usually, the cover, or black on the cage. So this is being printed in the Prusa 3 Mark 3. Okay. The other one, no, this one is the cage version. So as you can see, this is a 3D print FDM cage, the outer shell and the inner cage kind of using the cable core, like I think it's a millimeter thickness electrical cable. So I copper, so just strip it off and then bend it using a jig, like this, like a jig. I create a jig just to make it perfectly consistent in terms of the bend, and then glue it up into the 3D printing. Once you do that, you can just paint it with the base paint first, and then paint it black once it's dried up. So it will give you a black cover like this. So it's for the black one is for the fully cover is usually painted red, so much easier. And this one is a hinge, so I have to put a strip of kind of copper also into the base of the 3D, or the other half of the hinge. So it can be open, it can be closed. So it's actually working cover. So not only fixed cover when you cannot interact with it. So it's actually you can open up the cover and then push the button and you close the cover again. This one usually cover the Corey type switch. The red one, the full cover, usually cover the push button, the round push button. Okay. I'll show you the design of the panel making first. Actually, once you got the switch all set up, and actually I haven't shown you the the fire extinguishing button. So that's another aspect that I created, but it's a bit more complicated, so I didn't have the photo. So yeah, I'll give you the file also, but unfortunately I cannot explain that. But that is using the some latch push on off button also. So but anyway, once you deal with the switch, all of it, then you can actually, after that I create the panels, because once you have the switch you can kind of put the exact measure of the switch being used into the panel making. Okay, so panel making, I'm going to show you the how to do it by showing the Coreldraw. Okay, so this is the Coreldraw. That one, I'm sharing it also in the Google Drive later on. So it's actually have a triple layer. So each of the panels, this is the light panels, ice, anti-ice and lights panel. This is the aircon panel, electrical panel, fuel panel, fire extinguisher panel, and this is the side panel, and on the cargo fan panel here on the right, flight control left, right, and then ADIRS, and this is the PA and video. So this is panel. I didn't do a radio panel here, so just put a blanks, and also here is a blank. So these two panels is a blank. This is a radio, and this one is a audio. This is the third radio and audio panels as a backup. I didn't do this because it's not used, so I just put a blank cover. So each of the panel, as you can see, let's zoom in into this anti-ice and probe windows. It has three APU sign, top panel, mid panel, and bottom panel. So if you can see here, if I let's say I hide the bottom and mid, so it only show the top panels. So the top panel has engrave and cut panel. So engrave panel is for the letter usually, and also the side here. This is going to be engraved to expose the white, so it will lit also with from the backlit. This round and this square and round marking, so it's going to be light up also, including this letter. This line also going to be light up if you switch on the backlight from this overhead integrated light. So each of the panel has this is the top panel. If I close the top panel and open the middle panel, it will just show the holes, because it's just for the cutout of the switch. It's just to strengthen the upper panel. So this is a 2 mm. The top one using 2 millimeters opaque white, but the second layer is 2 millimeters clear white, clear acrylic. Okay. If we show the third panel is actually using 3 millimeters clear panels, but painted black on the rear side. The purpose is actually because I'm going to put a strip LED here, here, strip connected to together, 12 volt LED strip, orange or yellow color. When I switch it on or make it dimmer out of this LED, it will shine into the middle and top panel. Okay, the middle will diffuse a bit on the light from the strip LED to the surrounding, but the opaque white top panel, which is already painted and engraved, it only shows the letter and the letter, and so it's kind of like close to the letter and to the surrounding. So this will kind of spread the light across this top panel to light up the backlit. Okay, that's how it's kind of work in this file. So this is cover the whole overhead panels, and each of the panel have 3 layer at least. Some I think only 3 layers. In FA18C Hornet DCS, some of them are using 4 layers, but anyway, this is only 3 layer each. And if you can see that, here, the third layer, it has smaller square to ensure the Corey switch that I just showed you will not kind of loose to the back, or kind of so it's kind of like stop in the lips of the Corey switch aluminum casing will stay in the third layer of the acrylics. Okay, and you can glue it up with the hot glue, so that casing will stay in the third layer acrylics. And there are around 1 millimeter spaces between the inner switches and 2 millimeters outer top panel, so it won't kind of bind, so it's kind of enough space. If you see on the real aircraft panel also, there's a distance between the wall of the panels in the switch head of the Corey switch, so it's kind of quite okay distance. Okay, so the round one usually used for either for toggle switch. This one toggle. This one is for the potentiometer. And I connect this one into a LED dimmer, but not to the software. So I can directly adjust the dimming to the LED strip, but without any data being sent off back to the MS FS2020, because it's not necessary, because I just can dim from here the whole light, the backlight, and everything from here. Okay, so this is the overhead panels design, and this is for the screw. I'm not using the special screw that's very difficult to find, but I tried to find something like this. It's quite actually it's a minus Phillips screw, but with the square head, like a tapered head, not a round one, so it's tapered. And then I painted gray, blue-gray, similar to the panel color, and this looks perfectly fine. Rather than you use a plus type Phillips screw, round one is probably not matched. This one is quite similar with the original screw. I forgot the name though. What's the screw name? Anyway, you can comment down below. But this one is quite beautiful looking screw when it's installed. So this one is the this is the one that's already etched, and actually the second and the top panel and the middle panel, I glue it up with the acrylic glue, so it's stay together, and then you engrave it. Okay, this is a failed sample. I don't know why it's failed, but anyway, it's a failed sample. So this one is already engraved. The third acrylic panel will have a bit smaller hole here, so this one will rest in the third layer. Okay, and it's painted black, so it won't like shiny silver coming out of the hole. So yeah, so that is something like this. Should be not the correct one, but yeah, so it's something like this. So there's a distance between the switch and the wall, the second panel. You can see there's quite enough free distance for the switch to move up and down. So it's quite significant distance between this one. This one is a failed one, so I didn't really kind of able to engrave properly. So it's kind of like blurred the letter, but this one is, I think it's too much power that I use in here, so it's kind of like dig in too deep in engraving, so it's kind of look very bad. So yeah, this one is a much better one, but the installed one is much even better. So this one is just example, and the LED strip I'm using like this, so you can use the dense like 240 LED per meter, or 120 LED per meter should be sufficient. So this kind of like sitting in the third acrylic, but shining into this back panel here. So it kind of spread into the panels, but not going out to the top layer, because it's painted quite with several layer of paint and the base paint. Even you can paint a bit on with the black font first and then cover with the final color. But anyway, I didn't do that, but just the base gray paint, base paint, and then cover with this blue gray color. It's the final color. So yeah, so that is the panel making. You can see here, this is just the example of, I painted still wet, so I painted with the gray color, the final one, and once it's dried, it covered with some kind of flat clear color. This is from behind. This is the third. This is the third 3 millimeters panel. For example, this is with a smaller hole, and some of them are painted because it will show through this base on from the top and middle layer. Hold on. So this is the finished one. As you can see, it's quite beautiful. Almost like real. I'm quite happy with it. This one you can see with a darkening film, as I mentioned, right? So you cannot see the engraving white letter here, so it's like a dark, but when it's lit up beautifully. Now this one is the problem with the film. If it's used frequently, it kind of peel off, so I need to replace this with a new film. So if you perfectly fit it, it's gonna stay there quite beautifully for some time. So it's for a long time actually, until today it's not showing any peel off or something. But if you don't clean up your switch plate initially, there's some oil, probably the film will not stick. This one is the black cover that I mentioned, so it can be open and closed. There's a red one that not shown here, but I can show it later. This one is for the switch. Remember the toggle. This one is 3 position, 3 position. This one is 3 position. This one is 2 position, 3 position, and 3 position, something like that. So yeah, so this is the install panel. Remember also the screw. Remember the bolt, nuts and bolt. Basically, it looks really good, right? So almost good looking. Now, before I move on, I'm going to show you one of the. So you see this green one here? This is actually kind of very difficult to achieve. Initially, I was thinking how to achieve these green lines without, So I don't know what's the idea, but again, so what I did is I engraved a line here with a laser cutter. So it's actually an engraved lines. How to engrave it? Actually, I do like this. So I put the masking tape all over the top panels, and I laser cut and engrave it. So it's going to be perfectly aligned. So not going to use manual tape lining. So it's actually cut, engrave and cutting the tape. so expose the white acrylic, right? So I engrave it quite deeply with a strong laser power. So it's actually recessed panels, recessed line, actually becoming a recessed line. So once it's recessed like this, so I'm using Vallejo paint. This is for the model kits. Vallejo green, what do you call it? Green stabilo or something, very very bright green. So it's actually looking for this kind of paint is quite difficult, but then you kind of just dab around this recessed panel with those greens. So once it's dry, you can cover with clear flat color or first to secure the green, so it won't be kind of impacted during usage. So this is how I created those green marking lines in the panels. Yes, for information. That's additional information for you guys. So once you complete the panels, actually I built panels by panels, and then you start the installation. So the installation is this is the frame, the wooden frame, actually using MDF. So you working with MDF is very good, very convenience, because you can just attach each other using super glue or acrylate glue. So it's very strong glue, but it's very dangerous. You have to use mask. If you inhale it, it's going to be very dangerous for your lungs and health. So but it's very strong bond on MDF panels, especially before painted, of course. And you can put some what do you call it, yeah, so it's dust, sawdust, and then it's becoming like a very strong bond if you want to fill a gap or attach each other. So this is a pre-made frame using MDF, and then pre-cut, and then size is actually just enough for the panel to sit on top of it. So you install from one panel to each other and connect to it to the circuit using self register or directly to the Arduino to 560. Then for output, you have to drive via some LED driver. I'm using ULN 2003 driver. I'll show you later on a circuit in the electronic part. But once you use that, you can drive any LED. I'm using also special design chip. I designed myself. This one is I forgot the chip, or the chip called SM Sierra Mike 1612 Delta. So this is a LED driver chip. It's very convenient because this small SMD chip can drive 16 LED in this small board. So you can just put the shift register in using a shift register like a serial input, but the output is parallel. So this one is ground, and this one is this one is positive, and then this one is, because it's a pull down, so you have to give positive voltage, and it will pull down by the AC to light up. So this one is the LED driver. The other driver is using ULN type, so it's just manually using a resistor here, and the ULN 2003 chip is here, IC, and then it drives only 14 LED. Yeah, so just this one is for the pull up resistor before you connect this one into the Arduino 2560 input. So this one's for the input, this one is for 14 bits output, drive by the Arduino 2560 directly without a serial shift register, because you can use this shift register here, or for the input you can create also a shift register specifically for 16 bits shift register for input. So the switch will go here, and then it will shift back into the Arduino 2560. So you can save a lot of pins by using shift register. This one is for, I think we can drive 3 board like this, a shift register, you know what I'm saying, and 3 board like this. So you have total of 30, 16, 16, 32, 20, sorry. Yeah, I forget again. 16 is 32, right? 6, and then 48, yeah. if I'm mistaken. So yeah, so at least 3 board. If I'm not mistaken, or what do you call it? 6 AC, and this one also 6 AC, if not mistaken. Or actually only 2 and 2. I forgot. But anyway, MobiFlight is limiting its kind of ability to drive shift registers. Like MMJoy can drive almost like many of them in serial, but MobiFlight kind of limiting into 3 or what, I forgot. I'll have to check again. But anyway, this is how I drive the LED, and how I drive get the input from the switches. Okay. So once you, going back to the slide, I think once you install the panels and wiring up, you work on each panel and then end up with a lot of wiring, and it's very messy. Even I'm worried someday if something is broken, I might not be able to service it. Actually, this is where I tell you that initially I planned for easy to repair, replicate or redo the systems. Here, where I think it won't work because the design itself is too discrete. So to do that, actually you have to design the whole board. So it's kind of making less cabling here going around the switch, and yeah, so that's the only way to do kind of ability to recopy this design into many. But this one is just for one of a kind, so I'm okay with this messy cable because I just want to make it works, and it's working very well until today. But you just have to be careful with wiring. So you have to recheck and recheck again the wiring. So once you install, you screw it. This one is the example of the red tab or red closure. Some of the cage also painted red, especially for the fire. And then this one, this switch actually have a specific design of my own. So I'll share you the design, but I might not be able to explain on how to install it. I'm using dual on-off switch, a latch switch, just to stabilize. But there's a cage, there is a push button inside it. Yeah, the rest is actually, remember this circular small button. It looks definitely good for me, at least. The rest is just like this. Okay, so this is the final setting before I screwed down the panels into the frame. So this one is example of the testing. Testing the connection with MobiFlight. I pull out this cover first because I might want to pull out the switch in case it's not working. So this is testing the lights, the inside the Corey switch. So you can see the lights is perfectly good, no bleeding into the other side of the switch. So it's quite okay, at least for me. This one is actually testing the backlit, the LED backlit. That's a green line, is perfectly well lighted. You see, that's the black backlit is working quite okay. Now the problem here, I'm using the yellow LED, while actually the FCU is using orange LED. So I think initially I thought it's the correct warm white color, but the FCU that I bought from Java Simulation actually have an orange backlit, so it's kind of a slightly off color between the overhead and the FCU panel, or so I'm okay with it. So this one is actually the light testing of the LED. I'm using MobiFlight to scan all the lights output, so it's kind of like just rotating the signal through all the lights that is being connected. So just to check everything is light up. So that's how I check in the MobiFlight. Okay, so I think that is what else I forgot to tell you. I think it's sorry, long enough. Oh, sorry, the other one is actually, you see this, there is a voltage indicator here, the DC battery voltage. So I'm using these modules to connect the 7 segments. So I pull out this LED. Of course, I bought the one that is not soldered. I bought the one that has a kind of what do you call it, the IC holder or the heater, so I can pull out this and replace it with a 3-digit only LED, because it's only 3-digit. I think dual digit and one decimal behind, one number behind decimal, so 3-digit only. So I've replaced this 4-digit into 3-digit LED, a 7 segment, and then attach the LED directly to the panels and run a wire into this modules, and using this serial shift register LED 7-segment modules. Okay, so it's very cheap from China, so you can run one module to light up the battery voltage indicators. Okay, what else? I think I covered most of it. What else? I think that's it. Okay, so that is the design process of the overhead, starting from the Cori switch first, because I have to ensure the Cori switch is working perfectly well, and the other switch also, the size. And one more. I have you see this what do you call it, the wiper switch. So I'm using a different switch from something like this. So actually, I tried to use a rotary switch, but the problem with the rotary switch is not moving 90 degree. So it's only end up like almost 60 degree kind of angle, 1, 2, 3. So I need the switch to cover the whole 90 degree, right? I cannot find the proper switch until I found something like this in China or in AliExpress. This one is not the one. Actually, I bought a bigger one, kind of 22 millimeter size, but the switch actually is from end to end. It's actually 90 degree, 3-position switch into 90 degree. Now from here, I put a cover like this with the design on 3D to be able to sit on top of this specific switch. So it's kind of like yeah, so it's perfectly well, but again, it's on, off, on. So it's similar with the toggle 3-position switch. You have to run it through a NAND gate, a logic gate first, to get on. So you get 3-position on for the wiper switch. So this is the only unique switch that I tried to find with the 90 degree for 3-position one, like 0, 45, and 90 degree position for the rotary switch. So that's the only unique switch. I think you can find this. I think this is for the boat, a switch for the boat, something. The name is the switch for the boat in AliExpress. So this is the switch that I only find, that I can find rotating triple position from 0, 45 degree to 90 degree. Other than that, it's only max 60 degree in three position, so 20, 20, 20. So it doesn't really look good in the real overhead panels. Okay, so I think that's it for overhead. It's quite a long video, I know, because I have to cover a lot of what do you call it, a lot of ground in overhead switch, because it's comprehensive. It's most of the complex one of the complex panels in A320 cockpit is overhead, right? I think the most complex, actually, yeah, the most complex panels in A320 cockpit is overhead panel. Okay, after this it's easier. Of course, there are like pedestal which have a very difficult construction of the throttle quadrant. That's why I bought it rather than created my own, because it takes a lot of time to design the, although I might be able to design it, but it will take some experiment and try and error to come up with a very good throttle quadrant. So I just bought a throttle tech throttle quadrant and then try to fit in that things in the pedestal. Anyway, we're gonna talk about that later on. So I think enough talking. I'm going to stop here. Hopefully you find a lot of information about the overhead panel that I'm using right now in my DIY A320 Neo home cockpit. Okay, so going to be continuing to part 4 on the next panels. So see you there.